Assalamu alaikum, sir.
हेलो अस्सलाम वालेकुम।
Assalamu alaikum, sir.
जी आवाज आ रही है आपको? ठीक है, मैंने ये वेरीफाई करना था। ठीक है ना?
Yes, sir.
इट्स ओके।
Yes, sir.
कैन यू हियर मी
Yes.
क्लियरली?
Yes. 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 Yes.
All right. Okay, let me check how many participants are here. 1 2 3 4. Okay, 12 or 11 I think. All right, the first thing I would like to know would be how many total number of participants are there in this course? क्या आप बता सकते हैं?
Personally, sir, I don't know, sir.
All
Maybe the
right.
others.
But in any case, we would start right now without wasting much time. Let me introduce myself. My name is Dr. Syed Muhammad Asim. In short, you can call me Dr. Asim. Basically, I am a faculty member at Peshawar University of Peshawar. But for the last many years, I am coming to this PhD program of Qurtuba University and sharing some of the courses with them. And one of the course that we will be following is we are starting today. The name of the course is, let me show you. This is, okay, I think first I should share the screen and then you'll be able to,
Yes, sir. Yes, sir.
to look at that. Okay. Okay, can you verify that it is visible now?
Yes, sir.
All right, okay. So the course that we are going to follow in this semester, the name of the course is Advanced Quantitative Techniques. The basic purpose of the course, the details would of course become clear as we move further. But the basic purpose of this course is to give you an overview of all those quantitative techniques, advanced quantitative techniques, which can be useful for you as a researcher in the field of management science. So one of the main purpose of this course and also a subsequent course in the next semester that I will be offering, one of the main purpose would be that it should help you to use appropriate quantitative tools in your research, in your thesis that you will be doing after successfully completing your coursework. So let's directly go to the outline of this particular course. Okay. Broadly speaking, this course on advanced quantitative techniques, this will cover an important area in the field of statistical analysis. We call that area multivariate analysis. Okay, multivariate analysis, which I will introduce shortly, what we mean by multivariate analysis and what are the different types of multivariate techniques. In today's lecture, after introducing the idea of multivariate analysis, we will be learning some basic terms, which I would call something like learning the language of multivariate analysis, and some of the multivariate summary measures which we require for understanding the analysis. And there is also a very important idea involved in most of these techniques, and that idea is linear combination of variables. So what is linear combination of variables, why it is important, and how it is used in further analysis? So we would have a quick understanding of this idea. And then there are some measures that we call distance measures. So what we mean by distance and how it would be used for advanced quantitative techniques, this would be just an introduction to those measures. Okay. All right. Wajid is, I think, just saying that he couldn't hear. जी वाजिद, अब आप सुन सकते हैं? Hello, Wajid? I don't know. Lekin in any case, for example, if you can't hear it, ये हम workout कर लेंगे. But I hope you will also get the recording of this video, and hopefully that would help you. Otherwise, I don't know. From here, I can't do much to solve this problem, but hopefully you can just do something about that. Okay. बाकी लोगों को तो आ रही है ना आवाज?
जी सर, आ रही है आवाज.
All right. So after this very preliminary discussion of the basic terminology and different measures, we will particularly start discussion of various multivariate techniques, advanced quantitative techniques, starting with principal component analysis and factor analysis. So this would be mostly, I would say that each technique would be covered per week. Like each week, we would try to cover one technique, but sometimes because there would be some discussions involved in that particular technique apart from actual analysis of data using that technique. So maybe some of the topics would cover, expand over 2 weeks. So a minimum of 1 week and a maximum of 2 weeks would be required for covering each topic. Here I have just mentioned the topics. So principal component analysis, which in short is abbreviated as PCA, and a related technique, which we call factor analysis. This would be part of our discussion. Then we will come to cluster analysis, then discriminant analysis, and then the next technique would be multidimensional scaling and correspondence analysis. This would be the next set of techniques that we will be learning. And then we would come into a very important discussion of mediation, moderation, and moderated mediation analysis. And we'll be using an SPSS program, SPSS process macro for that purpose. And at the end of our course, we will be learning a very important area of quantitative techniques, which is called SEM, Introduction to Structural Equation Modeling. And basically, we will be using two major techniques in this area of SEM. One particular technique would be handled by a software called AMOS. So SEM analysis using AMOS. And the second one would be the partial least square structure equation modeling. And that could be actually covered by using another software that we call the Smart PLS. Okay. Most of you would find possible use of techniques that you can have for your thesis later on. I hope some of the students would find these techniques, which are broadly called SEM, quite useful for their analysis. Okay. And as you can see here, the software that we'll be using for the analysis would be SPSS. For many reasons that I would explain later, SPSS would be quite effective in learning all these techniques that we'll be discussing in this particular lecture, this particular course. Okay, here are some books which are useful, which are recommended for the topics in this particular course. The first two books are more general, which means they will cover almost all the topics that we will cover in this particular course. The first one is Multivariate Data Analysis by Hare, Blake, Babin, and Anderson, and Tatum. So I will call it Hare et al. This book is more tilted towards applied researchers, and particularly in the field of management sciences. So you will find this book quite useful for various topics that we will be discussing in this course. From statistical point of view, there is a very good book by the name of Applied Multivariate Statistical Analysis by Johnson and Witcher. I will call it J&W later on. And this is a very good book for having a clear understanding of various multivariate statistical tools. For the particular specialized topic, which would come at the end of our course that we call structural equation modeling, I am recommending two books for that. The first one is by Byron, Structural Equation Modeling with AMOS, Basic Concepts, Applications, and Programming. And the second book is that by Klein, which the title is Principles and Practice of Structural Equation Modeling. Okay, let me check. Okay, so I don't know. Can anybody recommend how to solve this problem? कि कुछ लोगों को आवाज नहीं आ रही है ना जी out of the current
सर ये रिकॉर्डिंग
जी
सर इसमें
जी
सर इसमें एक ऑप्शन नीचे आ रहा है लेफ्ट मोस्ट पे जॉइन ऑडियो लिखा हुआ है उस पे मेरा तो वो मैंने जब प्रेस किया था तो आई वाज एबल टू हियर यू सो मे बी बाकियों के लिए भी है जब आप मेन्यू नीचे देखें तो उसमें
अच्छा,
लेफ्ट पे
मैं उनको यहाँ लिख देता हूँ कि
जी जॉइन ऑडियो मैं खुद सर मैं भी लिख देता हूँ, खैर है।
प्रेस जॉइन ऑडियो।
जी जी।
अच्छा, लेट्स होप के दिस वर्क्स।
जी जी।
थोड़ा मेरा ख्याल है वेट कर लेते हैं। आई होप इट वुड बी जस्टिफाइबल कि बाकी पार्टिसिपेंट्स भी हमारे साथ हो ना, ऐसा ना हो कि हम आगे बढ़ते जाएं और वो अनफॉर्चुनेटली दे आर मिसिंग दिस थिंग। सो लेट्स वेट फॉर फ्यू सेकंड्स कि
ठीक है सर, ठीक है।
उनका रिस्पांस क्या आता है।
ओके। ना वाजिद से
ओके, गुड, वंडरफुल।
ना करना जॉइन आईडी हुआ।
जी, ये सजेशन किसकी तरफ से आई थी कि जॉइन ऑडियो?
सर ये मैंने दी थी, फहद अली।
व्हाट्स योर गुड नेम?
फहद अली सर।
जी,
फहद अली।
Fahad. So Fahad, I'm really very thankful to you कि आपने
नो प्रॉब्लम।
ये प्रॉब्लम सॉल्व किया। Actually, if some of the participants are not actually going along, तो वो मेरा ख्याल है फिर problematic है। जी वाजिद, can you hear me now? वाजिद को आवाज आ रही है?
सर वाजिद को मसला है सर।
अच्छा,
वाजिद साहब को
okay, so चले we would just आगे बढ़ते हैं। I hope के he can have access to the video recording of this lecture later on. ठीक है, next lecture में हो सकता है कोई फिर issue ना हो। Okay, so these are the books. One thing which I would like के अगर आप कर सकें, right? Let me see. अच्छा, अभी तक कुछ लोगों को नहीं आ रही। This is actually a problem.
खैर है सर, फर्स्ट डे है ये
हाँ,
मसला
फर्स्ट डे में टेक्नोलॉजी इश्यूज आते हैं एंड अनफॉर्चुनेटली आई एम आल्सो नॉट एन एक्सपर्ट। तो या तो हम कंसर्न जो कुर्तुबा में लोग हैं उनको रिक्वेस्ट कर देते हैं बाद में कि वो इन इश्यूज को देख लें कि हाउ टू सॉर्ट इट आउट। ठीक है, इज इट ओके इफ वी मूव फॉरवर्ड? ठीक है ना, बिकॉज टाइम फिर उसमें सारा वो लगेगा ना। ओके,
अस्सलामुअलैकुम सर।
जी वालेकुम सलाम।
सर मैं समझा शायद मेरी आवाज नहीं जा रही कहीं पर भी।
अच्छा,
अस्सलाम वालेकुम।
जी वालेकुम सलाम। अब मेरा ख्याल है ज्यादातर लोगों का मसला सॉल्व हो गया है ना?
जी जी सर, आवाज आ रही है। इशफाक अहमद, आवाज आ रही है।
ओके, थैंक यू। सो एक चीज यहाँ पे क्विकली मैं जरा आप लोगों से रिक्वेस्ट करना चाहता हूँ। इफ someone take this voluntarily कि अगर आप लोग मुझे अपना एक ईमेल जॉइंट भेज दें, because from time to time I would like to share some material with you in advance. अब देखें ना, आज तो हमारी पहला लेक्चर है ना, but for the subsequent lectures
मैं सबसे ले लेता हूँ।
जी, so I would just give my email to you in this online session. तो अगर आप सब लोग मुझे अपना email भेज दें, so that would help me कि if there is a relevant material that I would like to send to all of you in advance. तो वो lecture से पहले in a sense उस week से पहले मैं आपको भेजूंगा. So I hope when you will be coming to the lecture, so you will be in a better position कि आपके पास थोड़ा बहुत material advance में available हो. ये सही रहेगा ना अगर हम इस तरह कर लें?
सर हमारे पास
जी
एक
सर।
व्हाट्सएप ग्रुप बना हुआ है सर।
अच्छा
सर अगर हम एक व्हाट्सएप ग्रुप बना लेते हैं तो वो बेहतर रहेगा।
हाँ ये भी ठीक है, ठीक है। मैं
जी जी
आपको अपना मोबाइल नंबर दे देता हूँ, आप उसमें ऐड कर लें।
जी
और
जी सर।
अदरवाइज भी अगर ईमेल भी आप शेयर कर सकें तो वो भी बेहतर है ना, राइट? तो राइट, फॉर एग्जांपल आई वुड लाइक टू सेंड यू दीज 4 बुक्स, ये जो आपको अभी स्क्रीन पे नजर आ रही है ना, राइट? सो आई वुड लाइक
जी सर।
यू शुड कीप अ कॉपी ऑफ these books with you, because from time to time maybe I just directly go to a particular page of the book. So agar aapke paas already wo book available ho, so that could be quite useful. Okay, so at the end of this session we would just share the email and the phone number. Okay, right.
ओके सर।
So these are some of the books that you can see on the screen, and you will get a soft copies of these books. So hopefully that will be helpful. All right, let's start with multivariate analysis. Okay, still there is a problem, right? The word multivariate, as you can see, if you just look at the name of the word, it is multivariate. Multi stands for many, and variate stand for variable. So you can call it many variable analysis. Just to refresh your memories, I hope you have already attended basic statistics courses at some level in your previous programs. But one of the important concept in statistics is that of a variable, right? So can anybody tell me what is a variable? Just for the purpose of refreshing our memories. When you hear the word variable, what is your idea? कोई भी बता देना, just for the purpose of continuity. मैं चाहता हूँ कि we go along. जी.
Any characteristic, anything that can change its value with the passage of time, and that is the primary that is considered of primary interest.
All right, correct. 99% it's correct, right? So we say variable is a characteristic, it's a feature, it's a measurement which changes, right, from one unit to another unit. Remember, there are two things when you consider a statistical data, or in that sense a data. One idea is that of a unit. Like, for example, the unit can be a customer, it can be a respondent in a survey, it can be a country, it can be a student, right, etc., etc. And on those units you measure certain characteristics, or you do some sort of measurements. Like, for example, in a survey, when you are asking questions from the respondents, so each question is such a way that respondents may not give exactly the same answer on that question, right? So if you are asking about the age of the respondent, all the respondents may not be of the same age. If you are asking about the income, so all respondents do not have the same income. And if you are asking about certain opinion regarding a product or regarding any issue, you know that they would have different opinions. So in a sense, when you are doing some sort of survey, you know that every question in your survey plays the role of a variable, right? So variable is a characteristic, it's a measurement, it's a feature that you measure or you report for the units in your study, okay? So in that sense, when you have data on one variable, on just one variable, like you have asked from your respondents, what is your monthly income? So the data on just one variable is called univariate data, okay? univariate. And the corresponding analysis will be called univariate analysis. When you extend the univariate data by including two variables in your data analysis, right? Apart from income, if you also, for example, ask another question on their, let's say, level of education, okay? So now you are dealing with two
Age.
variables, and you say that I'm dealing with bivariate data. And the corresponding analysis of such data would be called bivariate analysis. So when you increase the number of variables in your data from 2 to more than 2, like 3 or more variables, then the data becomes what we call multivariate data. So in simple words, multivariate data would refer to a data set consisting of more than 2 variables, okay? In the analysis of multivariate data would be then referred to as multivariate analysis, okay? Let me show you something.
Yes, sir.
The software that we'll be using in this particular course, that software, let me also ask this question. Is there someone in this course who is not familiar with SPSS, or are you all familiar with this software?
So, sir, I am not familiar, but just run my SPSS data on SPSS with the help of my friend when I was doing my MS thesis.
Okay, no problem. Is there any other person who is not familiar with SPSS? Okay. Let me tell you, whether you have used this software before or whether you have not used it before, it's not a problem, because SPSS is one of the simplest statistical software, and it's easy to learn, right? One of the advantage of SPSS is that it is much easier to learn as compared to any other statistical software. Keep in mind that SPSS would be an integral part of this course. When we will be learning different techniques during this course, in each session, I will be using SPSS for explaining the main idea of that particular technique. So if you wish, we can also have a quick session of the basic operations of SPSS in one of our other sessions. For example, at the start of the next week's discussion, I can just give you a very quick, like 5 to 10 minutes introduction to SPSS, okay? And that would be only for those participants who have not used it before, just to show that it's much easier to use SPSS as compared to any other software. So don't worry if you have not used it before, you will not have any disability for that, okay? For the time being, I'm not actually going to introduce the SPSS, but I just want to show you something without explaining how this software works. I want to show you some data sets which are part of this software. And I just want to explain a point that I have started right now. Just like any other software, SPSS has got sample data files which are located at a particular location, which I have opened right now. So in this location, there are a number of data sets. These are actually practice data sets, some of which would be used during our discussion in this course. And if you, for example, if I open up this data set, right? If some of you are already familiar with Excel, then the data interface of SPSS is just like Excel. Like, for example, you would have a spreadsheet where each column would represent a variable, right? Each column represents a variable and each row represents a unit depending on what is your unit. It may be, for example, a country, it may be a company. So this data set consists of two variables. One is advertising spending, and the other one is detrended sales, or you can just call it sales. This type of data is what we call bivariate data, okay? Because it has got two variables, advertising expenditure and sales. But if you look at any other data set, if I just open up any other data set from here, let's say I open up this particular data set of bank loan. You see now the number of columns are more than 2. And as I have told you, each column in this data set represent a variable. Like, for example, the first column represent what we call age in years. Okay, so this data is about loan applicants who have applied for bank to a particular bank for loan, and the bank has got actually information from the loan applicants. But for the time being, the purpose is not to explain the whole nature of data. The purpose is to tell you that each column in this data set, the first one is age in years, the second one represents level of education, the third one represents years with the current employer, then years at current address, then household income in thousand, debt to income ratio, credit card debt in thousands, other debt, right, etc., etc. So if you look at this particular data, which were taken from okay, so G, who wants to talk?
So this is me, Fahad Ali. I just had a question. So am I allowed? Okay, so in univariate analysis, you said that we only have one variable.
Yeah.
But I haven't seen ever any research where we have just only one variable throughout the study. So where do we use such analysis? I mean, where we just have only one variable and nothing else.
In statistical language, let me explain this point. When we use the word univariate analysis, actually we are trying to say that your variable of interest, your main variable of interest is just one variable, okay? So for example, if you want to study just one phenomenon like the sales over a number of years or the sales of different companies, without, for example, in one of the topics that probably we will be considering in our next semester, right? Next semester we would have a course on applied econometrics, and there I would be able to explain this particular point a little bit in more detail, but I'm just trying to give you an idea. For example, you could have a data on just one variable, which I have highlighted here, sales, okay? This may be sales of a company for the last, let's say, how many cases are here? Okay, 24. So we have 24 serial number 1 up to serial number 24. So imagine that we have got the data for a particular company for 24 years. And the data is something like this, okay? So for one single company, we have the figures of sales for 24 years. And using this particular single variable data, we want to predict the sales for the next few years, Okay. So our purpose is to predict the extent of sales for the next year and afterwards on the basis of data available to us for the last 24 years. So there are particular statistical techniques which you can use to use the data on this single variable to forecast or predict the sales for the next 4 years, for the next 5 years, for the next 10 years, and so on and so forth. So in that sense, even a single variable data would be enough, right? So depending on the nature of your research question, the researcher can decide whether I should have data on just one variable, like only sales, or whether my research question requires that apart from sales, I should also collect data on other related variables which can tell me something about the phenomena of sales. So if your research question demands, you would say that apart from sales, I would also collect data on advertising expenditures. I would also collect data on 2, 3, 4, and 5 other variables. But remember, your variable of interest will remain just one, and that will be sales. So as long as your interest lies in a single phenomena like sales, from statistical point of view, that sort of analysis would be declared as univariate analysis, right? So even if you are trying to relate the advertising expenditure with the sales phenomena, but as long as your variable of interest remains a single variable like sales, then we will call it a univariate analysis. When our interest is not just in sales, but also in advertising expenditure, and we say how the two are related to each other and so on, then we would say that we are entering into bivariate analysis, right? So this is how we extend the phenomena from univariate to bivariate and ultimately multivariate. For the time being, is it okay?
Yes, sir, absolutely fine. Thank you, sir.
Okay.
Absolutely fine.
Because there are many sort of things which would become clear as we move forward. So don't expect that you will get answers to all your questions today, right? To be fair, I would say that it's wonderful that you have a lot of questions in your mind, but don't expect that we would be just dealing with all those questions, right? It's good to have questions, but sometimes you have to wait for the appropriate time to get answers for your question, right? So therefore, from time to time, we will be just going ahead into different directions in our courses, and hopefully at various places within our course, you will find answers to your questions. The point that I'm trying to make is this. If you look at this data set, then by definition of multivariate data, this is what we call multivariate data, right? Why? Because in simple words, when the number of variables in our data set are more than 2, then it becomes a multivariate data. And this basically tells you that real life data sets are almost all the time, if not all the time, or almost all the time multivariate. Because consider any data set that you can possibly use for your research, and you will find out that most probably it would be a multivariate data. So this is one actually justification why you need to know appropriate multivariate tools, right? Just for the purpose of example, I would show you one further data set before I go back to slides. You see, for example, if I just open up this survey sample, so this is a data set in which information were taken from as many as 2,832 people. Okay, so this is just a sample survey. Of course, it's a fictitious survey. It's not a real survey, but the purpose is just to give you an example file. And from these 2,000 plus people, information on various aspects have been collected, as you can see here. The labor force status, the merit status, the number of children, the age of respondent, highest year of school completed. So these are some of the personal information, followed by some information on different aspects, like think of self as liberal or conservatives, etc., right? General happiness, okay? For example, how much happy you are, very happy, pretty happy, not too happy. So these are, this is also an example of multivariate data in which people were asked different questions related to different aspects of their life. And as you can see here, starting from column number 1, and now there are a much more larger number of columns as compared to the previous data set, right? So not only the number of units, the number of respondents here are more than 2,000, but the number of variables in the form of different columns are also much larger. And in real life, you can expect even much bigger data sets than what you can see right now on the screen. I hope some of you have already heard the name of big data, because nowadays we talk about a terminology which is called big data analytics. And big data are also quite common in business and management sciences. So whenever you use the word big data, be very clear that big data is nothing but a multivariate data, right? So as the structure of data become larger and larger, new issues come into force, and you need new techniques, advanced techniques to handle with such data sets. So therefore, one purpose of the lecture of this course would be to extend your knowledge from the simple statistical analysis to much more broader advanced techniques, which are particularly suitable for dealing with a bigger structure of data. So this was just something about the meaning of the word multivariate. So I hope now it's quite clear to most of you. Yeah, please. G. Yes. कोई आप पूछना चाहते थे? जी इशफाक
जी मैं कह रहा था, आपने जो भी डेटा दिखाया था,
जी जी,
इसमें से 2 टर्म हमने पढ़े थे, नॉमिनल और ऑर्डिनल स्केल, इनको थोड़ा सा काइंडली एक्सप्लेन करेंगे आप प्लीज?
Okay, we will go to that, but let me quickly tell you something about that. If you look at this
Yes,
data, okay, or maybe let me show you the other one.
Yes, sir.
The survey sample, okay. If I go to the details of the variables, broadly speaking, I would say that the data can be divided into 2 categories. One is called quantitative data, and the other one is called qualitative data, okay? By quantitative data, we mean if you can express the data obtained on certain variable directly in the form of numbers, then that would be actually a quantitative data. Like, for example, if you look at the variable age here in this fictitious survey sample, so if you ask people what is your age, the answer would be directly in the form of some number. Like the first respondent is saying 60 years old, the second respondent is reporting his or her age is 27, etc. So if the data are directly recorded in the form of quantitative numbers, we call it quantitative data, right? But for example, if the data, let's say merit status is actually a variable which in statistics we call categorical variable. So for example, if you ask people, what is your merit status? So the possible answers can be married, widowed, divorced, separated, never married, for example, okay? Initially married versus unmarried, but if you want to go into the detail, then you can say widowed, divorced, and so on. Such type of variable, which cannot be directly expressed in the form of numbers, rather in the form of categories, then such a variable is called categorical variable, qualitative variable, or categorical variable. A qualitative variable or categorical variable can be further divided into two categories. It can be a nominal variable, or it can be an ordinal variable.
Ordinal.
So for example, if you just look at this particular variable, merit status, okay? Then, for example, the first category, particularly in this data set, which is coded 1, is married. The second
क्वालिटेटिव की बात हो रही है सर?
Sorry?
ये क्वालिटेटिव की बात हो रही है?
Yeah, exactly. Quantitative variable is simply a variable where the data can be directly expressed in the form of numbers, while qualitative variable or qualitative data in that sense would refer to that variable where you cannot express the possible values directly in the form of numbers. Rather, it would be in the form of different categories. As you can see here, marital status of the respondent is a categorical variable, a qualitative variable, because it can be expressed in the form of different categories. As you can see on the screen right now, married, widowed, divorced, etc. So as long as the possible answers, the possible values of a variable cannot be expressed directly in numbers, rather in categories, you will call it categorical variable or qualitative variable. But what I'm saying that even a categorical variable can be further divided into two categories. If you look at this variable marital status, although you can see that the first category is married, the second is widowed, the third one is divorced, and so on. But we say that there is no particular order. There is no particular order in the categories. Like, for example, rather than married as the first category, if you take widowed as the first category, it would still not make any problem. Okay. So if there is no particular order or required order in the categories of a categorical variable, then such a variable would be called nominal variable. Okay, nominal variable. Like, for example, if you ask a person, what is your gender? And the answer is in the form of male or female, then it doesn't matter whether male should be the first category or female should be the first category. So those categorical variables where there is no defined order in the categories, then such variables would be given the name of, as you can see here, nominal variable. But there are certain variables for which the order makes sense. For example, if there is a particular variable in this data set by the name of degree, okay, you see, and the different categories of that degree is less than high school, junior college, bachelor, graduate, and so on. Or in general, when you are asking someone about the level of education, you know that it would start from something like no education, then up to primary, then from primary to middle, and so on and so forth. So you see, in such categories, there is a defined order. It should go from one end to another end. So if there is a defined order in the categories of a qualitative variable, then such a variable will be given the name of ordinal variable. Ordinal. So ordinal means that there is a defined order in the categories. But nominal means that there is no defined order. So therefore, qualitative variable can be nominal or it can be ordinal, right? Like, for example, when you are asking an opinion question in a survey, and if the possible answer to that opinion question is in the form of strongly agree, followed by agree, then neutral, then disagree, and then strongly disagree. So you see, there is a defined order from strongly agree to strongly disagree. So if there is a defined order in the different categories of a variable, you will call it ordinal. But if there is no defined order, like for example, if I ask you, what is your profession? Okay. If I ask all of you, what is your profession? And you give me different names, like someone is a government servant, someone is doing his own business, and so on and so forth, then I would say that the variable profession or occupation status is actually a nominal variable, because it doesn't matter which category should be declared as the first category and which category should be declared as the second category. So if there is no defined order, you will call it nominal variable. If there is a defined order, you will call it ordinal variable. But if you are dealing with quantitative variable, although you can further divide it into interval or ratio, but usually we say we are dealing with a quantitative variable. As far as SPSS is concerned, it would use the word scale, SCALE, for a quantitative variable. Okay, so there is no need to mention whether it's a interval level variable or whether it's a ratio level variable. We would just combine those two and we would say that we are dealing with a quantitative variable. But for qualitative variable, you can then make further identification, whether it's a nominal variable or whether it's a ordinal variable. G. Fayaz, is it okay?
Sir, is it absolutely okay?
All right, thank you. Okay, so G, please. G.
As you talked about the definition of ordinal variable and in other variables. So if you want to measure the height of any individual, it
Right.
also comes under the definition of ordinal variable, because still I remember that when you were teaching us on MS level, still I do remember the same example, sir.
Well, let me just put it this way. Any quantitative variable for the purpose of your research can be converted into a categorical variable. Okay. Any quantitative variable, like for example, the age of the respondent, as you can see here, age is basically a quantitative variable. But if it makes sense for you, then you can just divide it into age groups, right? You can divide it into age groups, age group number 1, age group number 2. So when you convert age into age groups, this would become a categorical variable. And in this sense, it would become an ordinal variable. So depending on the nature of your interest, you can express a quantitative variable in the form of an ordinal variable. Like for example, as you can see here, this variable that you can see on the screen right now, okay, this represents the years of education, okay, years of education. But if you wish, you can just convert it into an ordinal variable where you can just make groups from the years of education. So therefore, yes, a quantitative variable can be expressed as an ordinal variable if it makes sense for your research. Otherwise, you can just record it as it is. But the reverse is not possible. I mean, if I'm dealing with a categorical variable, like for example, you see the marital status. If I'm dealing with a categorical variable, whether nominal or ordinal, I cannot express it as quantitative variable. I hope you are all quite clear on this, that the numbers that you can see in this column representing marital status, they are not actually numbers, they are just codes, they are just labels. Like 3 is not actually 3, it is just representing a particular category of the marital status, right? So therefore,
yes, sir.
For the purpose of analysis, you assign codes to the different categories, but the codes does not mean that it becomes quantitative. For example, in case of 3, if I just write down 30 here, and instead of 50, if I write down 55 here, it will still mean the same thing. So therefore, yes, partial answer to your question is that sometimes a quantitative variable can be represented in the form of an ordinal variable if the researcher is interested to convert it into an ordinal variable, right? But the converse is not true. A variable which by definition is qualitative cannot be expressed as quantitative. Only for the purpose of analysis, you just represent it by using the different codes. But codes does not make a variable quantitative. It will remain qualitative. Okay. So let me go back to my original discussion of introduction to multivariate analysis. So what is multivariate analysis? Expression of multivariate analysis is used to describe analysis of data that have numerous variables, which I have just explained. By numerous variables, I mean many variables, or usually more than 2 variables, or where observations are obtained for each individual or unit studied. In a typical survey, 30 to 100 questions are asked to each respondent, right? This is just for example. For example, in describing the financial status of a company, an investor may wish to examine 5 to 10 measures of the company's performance. Commonly, the answers to some of these measures are interrelated. This would be another phenomena that we will be dealing in this course, that when you are dealing with many variables in your data, then there is a phenomena of interrelatedness. There would be a phenomena of correlation among the variables. And this would actually pose a challenge, which we will try to handle using these advanced multivariate techniques. The challenge of disentangling complicated interrelationships among various measures on the same individual or unit and of interpreting these results is what makes multivariate analysis a rewarding activity for the investigator, right? So as I said, the multivariate data would pose new challenges, which are usually not visible in simple univariate or bivariate data sets. So therefore, there is a justification for advanced tools from multivariate analysis to handle with such complexity of the data. Often results cannot be attained without multivariate analysis. Okay, when you are dealing with a much larger data sets, there is no other option but to make use of multivariate analysis tools. At this point, I must tell you that there was a time when high-speed computers were not available, when most sophisticated softwares were not available. So multivariate analysis was not that much common in real research. But you know that nowadays there is no problem with softwares or high-speed computers. So because of the computational aspect of multivariate analysis tools, as you discover from our discussion in subsequent lectures, all the multivariate statistical tools that we would learn in this course, they are computationally intensive. So because computational facilities were not that much readily available in the past, so people were not using these techniques that much often. But nowadays, there is no problem as far as the computer software is concerned or the computing facilities are concerned. So multivariate analysis is now much commonly used in real research as compared to practice in the past. And you will see that the availability of statistical software like SPSS would make it quite easy to carry out those advanced techniques. But before we can go for that, let me introduce 2 terminologies that I'll be using quite a lot in my discussion. The first one is variable, which we have already clarified. There are 2 particular aspects of multivariate data. One is the variable and the other one is the object. Variable is the measurement or feature taken or recorded on some unit. And the second phenomena is that of object. Another name for object is unit or individual, or you can also call it the entity. An object is the entity on which a variable is measured or recorded. So the SPSS data sets that I have just shown you on the screen, each column of that data set represented a variable, while each row of that data set represented an object. This distinction would also become very important because as we will move forward, I will tell you that when you're looking at the data set, okay, let me show you again the multivariate data set. This is a multivariate data set in which each row represents the object or the respondent, and each column represents a variable. So there would be multivariate techniques which would look at this data like this, right? We call it looking at the data column-wise. And we will call it variable-focused approaches, right? So which means when you look at this data column-wise, then we call it variable-focused approaches. So it means you are interested to analyze or compare the variables with each other. The other approach would be to look at this data like this, okay? Which means looking at this data row-wise, the first row, the second row, the third row, the fourth row, and something like this. So when you are looking at this data row-wise, we call it the object-focused approach or the row-based approaches. So there will be some multivariate techniques which will consider the data row-wise, which means you're interested to compare the units with each other. Like, for example, if the units represent respondents, then you would say, I want to just do something by analyzing the rows of this data matrix, of this particular data, multivariate data, okay? So therefore, yeah, please.
अगर ये कहूं कि जो आपके पास जो ऑब्जेक्टिव है, ऑब्जेक्ट है, वो आपका वर्टिकल होता है और जबकि आपकी जो रो होती है वो आपकी हॉरिजॉन्टल होती है, तो ये ठीक रहेगा?
For example, usually when we talk about multivariate data, so if you look at this vertically, then you are actually looking at variables. So variable in a sense is the vertical dimension of the data. आप इसको इस तरह देखते हैं.
ठीक है सर.
But if you are looking at this data row-wise, which means if you are looking at this data horizontally rather than vertical, then the horizontal dimension of the data actually represents the object or the unit. Okay. So later on, when we will be talking about different multivariate techniques, apart from other classification, a classification में ये भी होगी कि whether you are interested in the columns of this data set, which means whether you are interested in doing something on the variables in your data set, or whether you are interested in looking at this data row-wise, which means you want to do something on the objects. Any simple example आप इसका ये ले लें कि for example, if the rows represent different companies, okay, company number 1, company number 2, company number 3, and so on, and if the columns represent, for example, different financial features related with those companies. So if you are analyzing the data row-wise, it means you want to do something through which you can compare companies with each other on the basis of those variables. But if you are analyzing the data column-wise, which means that you want to compare the different financial features with each other for each company, right? But if this point is for the time being not that much clear, don't worry, because this would become clear as we move forward. सिर्फ आप ये याद रखें कि you can be variable focused in your approach, or you can be object focused. And sometimes you can be having both the approaches together. आप उसको row wise भी देखना चाहते हैं for some purpose, और आप इसको column wise भी देखना चाहते हैं, right? So sometimes there would be just a uni focused approach. Sometimes there would be double focused approach. Row wise will give you answer to one question in your research. Column wise, you will get another answer for your research. Okay? So therefore, these will be the two things that we'll be focusing on in our next discussions. So that's why we say that you should be very clear what we mean by variable in our data set and what we mean by object in our data set. Okay. Next. These are some of the examples of multivariate data sets, but I hope now it would be very clear that, for example, from example number 1 on the screen that you can see right now up to example number 10, it is just telling you that what can be the possible units or objects and what can be the corresponding variables. Okay. One simple example, which sometimes I would be just mentioning in my discussion for the purpose of explanation. Like, for example, if I consider your class, so there are something like 15 participants right now who are attending this particular course. So if we consider these 15 participants, then each one of you, by the definition of our discussion, would make you an object. So I have, in a sense, 15 objects. Okay. And if I consider data on the marks obtained or the scores or the grades obtained by these 15 students on the different papers in the PhD. For example, I hope you are attending 3 courses in this semester. Is that right?
Yes, sir.
Okay, and hopefully you will be following another 3 or 4 courses the next semester. So imagine that in total, you are following 6 courses. Okay, so 3 in this semester, 3 in the next semester. So imagine that at the end of your second semester, we have data on your scores for all those 6 courses. And if I just arrange this data in the form of what you have just seen over here, okay, so each row would represent a student from 1 to 15, while in the columns, I would have scores in course number 1, course number 2, course number, right? So for example, I would have something like this. Okay. Let's say I have course 1, course 2, course 3, course 4, course number 5, and course number 6. You see, this type of data that hopefully we will be able to have at the end of your second semester. Each column would represent a particular course, in this case 6 courses, while each row would represent a particular student, a particular scholar. So for example, scholar number 1, scholar number 2, up to scholar number 15 or 16, whatever is the total number of participants. So you can imagine that we could also have a smaller multivariate data set even from your class. Okay. So if that data is computed for 16 students, for example, we have scores such that for each student, we have 6 figures, right? For student number 1, we have row number 1, which includes 6 different numbers, where each number would represent a score. For example, let's say out of 100 in that course. This would also be an example of a smaller multivariate data set, where each row would represent an object, in this case, a student, and each column would represent a course, right? Because not all the students would get the same score on each subject. So the score on each subject would be an example of variable. And later on, I may be interested to analyze this data of scores on 6 courses for 16 students. I can analyze it column wise, because I may be interested to compare the courses with each other, or I would like to compare it row-wise because I would like to consider the performance of students with each other. Which students have a closer performance to each other and which students have a different performance from each other. So later on, when I'll be talking about variable focused approaches versus object focused approaches, I hope I can just come back to this hypothetical data and I can tell you which purpose would be served by the variable focused approach and which purpose would be served by the row based approach. So therefore, these examples that you can see over here, these examples of the different data sets that you can see over there from different fields, they are just telling you, for example, what can be the example of a multivariate data set from different fields. We would be just considering some of them in our later discussion, so I would just skip it for the time being. Okay, let me come to this important concept. Data matrix. A data matrix is a matrix containing multivariate data. Okay. The starting point of multivariate data analysis is to represent the data in the form of a matrix, and that matrix would then be called a data matrix. Remember, a data matrix simply takes the same multivariate data that you saw on the screen a few while ago and represent it in the form of an N cross P matrix. Let me just use this facility to highlight something. If you look at this particular matrix that you can see here, these rows are actually representing the objects. Okay, for example, the students. So in general, we have n objects in our study. 1, 2, 3. These are just serial numbers, or these may be the names of the objects, like the names of the students, the names of the companies, the name of the countries for which you have collected the data. So in general, we say we have data on n objects. And these are actually the variables whose title are x1, x2, up to xp. So these are actually variables, and these are basically the objects. And each column in this particular data set, in this particular matrix, by the way, this is actually an N cross P matrix. Okay, N cross P. N cross P matrix means, I hope most of you are familiar with matrix algebra, right? A matrix is a rectangular array of numbers, okay? And matrix algebra is quite useful whenever you are dealing with larger structures. And keep in mind that multivariate analysis, because of its huge structure, almost all multivariate analysis are actually based on considering the ideas from matrix algebra. That's why the starting point of multivariate analysis is to consider the data in the form of a matrix. The internal structure that you can see here, they are similar to what you saw on the screen a little while ago, okay? Each column in this matrix represent values of the corresponding variables. So for example, this column number 1, right? This column number 1 that you can see here, this one. This is just representing what? X1. X1 is just the title of our first variable, for example, age or whatever. So the possible values of x1 are x11 for the first object. Remember, each entry in this matrix is having 2 subscripts, right? in general, we say that each entry is of the style Xij. Okay, each entry is of this style, where I is representing the row number and J is representing the variable number. So for example, when you say X11, it is the value of the first object, right? First object on the first variable. X21 is the value of the second object on the first variable. So you see the second subscript is all 111, while the first subscript is changing from 1 up to n. And similarly, the second column in this particular matrix is representing X2, right? In statistics, we usually use these symbols for the variables, X1, X2, X3. So in general, we say that in multivariate analysis, you will be dealing with P variables, right? So this N is the number of objects, and this P is basically the number of variables, okay? So this would be general notations that you should all be familiar right from this point onward. Although my purpose would not be to go deeper into the mathematics of every multivariate technique, but it would be useful that you are also making yourself familiar with some of the notations of the multivariate data analysis. So right from here, the capital X would be the notation for data matrix, right? As you can see here, data matrix. So data matrix would be represented by the symbol capital X, and the entries within this data matrix starting from X11 up to XNP, these entries would be actually representing the individual values of our data set. These titles that you can see on the top, they would usually not appear in a real matrix, but here it is only for the purpose of explanation, that each column represent a variable which would have some title. Each row represent an object which would have some name or a serial number, right? In subsequent discussions, these 1, 2, 3 up to n and these X1 up to XP would not be actually visible on the screen, but it is only for the first time. So therefore, if you look at this data column wise, then each column is basically representing the particular variable. So column number 1 representing X1, column number 2 representing X2, column number 3, and so on up to column number P. So if you look at this data column wise, this is what we call the column based approach, right? But if you look at this data, for example, row wise, if you look at this data like this, rather than column wise, if you look at this data, something like you said, this is my first row, and you say that this is actually representing X1. This is my second row. And this is representing X2. And this one, so on, is my last row, which represents the last object. So if you're looking at this data matrix row-wise, then you are actually having the object-focused approach. And you say that each object in this matrix can be represented by a multi-dimensional vector, right? I hope you remember that every row or every column of a matrix is basically a vector. So the first row is a vector of observations. The second row is also a vector of observations. And the third row is also, the last row is also a vector of observations. So when we'll be later on carrying out multivariate analysis of our data, remember, depending on whether we are having the variable focused approach by looking at this data column wise, or whether we have the row based approach by looking at this data row wise, we will be considering the data in the form of these vectors. First vector representing the first student, second vector representing the second student, so on and so forth. Okay, so you see, this is actually what we do. And in general, we say that we are dealing with an N cross P data matrix. So remember, this data matrix, for most of the multivariate analysis, this would be the starting point, or at least when the software will be giving you results of your analysis, the software may not show you on the screen that this is actually the data matrix, but you should be very clear that the software would first consider the given multivariate data in the form of this X matrix. And from this X matrix, it will do further calculations. Okay, all other calculations would actually be computed from this X matrix. So this would be the starting point of multivariate data analysis. Why I have introduced it? Because if you hear this word data matrix from me during the discussion, so I hope you will not find it very difficult what I'm talking about. Okay. This is the first concept with which you should be familiar. The next concept is that of what we call multivariate summary measures. Can I just do it like this? Okay. Multivariate summary measures. The symbols that you can see on the screen right now
so we have another class as well as 11 a.m.
Sorry?
So we have another class as well as at 11 a.m.
Okay. So maybe we can just stop right now. But at the start of the next lecture, I would be quickly introducing some of these summary measures. The purpose is not to go into the deeper details of these, but because these concepts would come into our discussion. Like, for example, I would be using the word sample mean vector. I'll be using the word sample covariance matrix in my discussion, and I'll be using the word sample correlation matrix in my discussion. So at the start of the next lecture, I would just give you a quick idea of what these things are all about. Because once we start the actual analysis of data, then you will see that these measures that we call multivariate summary measures, they will play a very important role in our discussion over there. Okay, so with this, we just would stop it right now. If you would like to send me your emails, let me write down those things, my email over here. Okay. Let me write down the email. So this is my email, sasim@uop.edu.pk, and the mobile number 0333-920-3818. Okay. So if someone can actually send me the email of the participants of this particular course, and alternatively add this number to the WhatsApp group, so we can just share some of the material of this course with each other. Okay. Thank you very much. Okay. Thank you. Thanks a lot. Okay, with this we come to the end of.
मैं कुछ बोलना चाहता हूँ
जी please.
सर मैं कुछ बोलना चाहता हूँ
जी please.
जी मुझे सारे दोस्त सुन रहे हैं
जी
आप काइंडली इधर ही मैसेजिंग चैटिंग पे आप मुझे अपना मोबाइल नंबर और अपना ईमेल नंबर दें तो मैं उसको फिर कॉपी करके वर्ड पे ले जाऊंगा और मैं सर को ईमेल कर देता हूँ इन वन गो।
अच्छा, ये तो मैंने अभी लिखा भी है और वो आया भी है स्क्रीन पे, राइट? मेरा ख्याल है कि इट वाज समवेयर।
नहीं सर आपका हमें मिल गया है, मैं अपने फ्रेंड्स को कह रहा हूँ कि अगर आप सारे इधर ही दें तो उसको फिर कॉपी के हम आपको भेज देते हैं।
अच्छा, मेरा वाला तो आपको मिल गया है ना, राइट? ओके ओके, ठीक है।
जी जी सर आपका मिल गया है सर।
Okay, so thank you very much. With this, we just come to the end of this discussion. Thank you. See you in the next week. Thanks a lot.